Okay, class. I wanted to go over some notes. Some classes were a little bit behind, so I'm just going to refresh the first page of day 2 notes. So the first page of day 2 notes was linear relations, and we talked about how we can write in standard form. So in standard form, you'll see over here, right, that you want ax plus by equals c. Okay, and so I have some examples here that we had went through. But what's important to know is that you need to make sure A is greater than or equal to 1, so it cannot be negative, okay? So if A is negative, the number in front of X, if it's negative, then you would need to divide, like number 2, you need to divide everything by negative 1. By doing that, it makes it positive, and so as long as A is positive, you're good. The next question you want to ask yourself is A, B, and C, are they reducible? So does that mean, is there a greatest common factor that can be taken out of all 3 of them? And so for number 2, there's not. But I want you to go ahead and look at number 3. And so number 3, we're going to move the 24 over because we want ax plus by equals c. So we want the c on the other side. So we're going to add 24 to the other side to move it over. We then get 9x plus 6y equals 24. And you're like, okay, well, x isn't negative. I'm good. But the issue is 9, 6, and 24 all have 3 in common. And so you actually want to divide everything by 3 because it's like reducing it, okay? And so now you have 3x plus 2y equals 8. Okay, so these were the notes from Monday. And so I want to kind of go over some new stuff today. So the new things we're going over today is now slope-intercept form, okay? Slope-intercept form is actually one of my favorites. It's y equals mx plus b, okay? And so y equals mx plus b, or f of x is equal to mx plus b, because now we know function notation, is very interesting because the m is the slope, so we can see it right away, and the b is the y-intercept. And so we can actually graph that because the y-intercept is always going to be x is 0. So it'd be 0, comma, and then whatever the y-intercept is. So it's like a given point, which is really nice. Okay. We can also think of slope as a rate of change. So if you ever in a word problem or anything see rate of change, then that's another word for slope. We also think of it as rise over run. So when we're graphing it, it's the y values on top of the x values. And so we can rise up or down, depending if it's negative or positive, and we can run left or right, depending if it's positive or negative, okay? And so what I want to show you is the 4 types, okay? The 4 types of slopes. So the first one is going to be positive. So if I read the graph from left to right, okay, from left to right, it's going up. So it's increasing. If I read the graph left to right and it's decreasing, then you're going to have a negative slope. If I have a horizontal line, the slope is 0, okay? And a good way to remember that is horizontal has a z in it and 0 has a z in it. And so I always remember horizontal is 0. Okay, that's a good way to remember it. Vertical, if I have a vertical line undefined. Kind of rhymes a little bit, okay? So your vertical line, you're going to have an undefined slope. And that's because it's going to give you a 0 in the denominator, and we're not allowed to have zeros in the denominator, okay? So these are the 4 different slopes that we can get for a line, okay? So with being in y equals mx plus b format, like I said, we can grab the y-intercept really easy. So if I look at number 7, I can see that 7 is my y-intercept. That means 0, 7. So if I go from 0 up 7, I get this point right here. From that point, I have a positive slope. So I can go up 2 and to the right 2. To the right 5. So up 2 to the right 5 because it's positive. But it also can go negative as long as the other one's negative, because a negative divided by a negative is a positive. So I can go down 2 to the left 5 from this point. And the reason that's important is because if I run out of room, right? So if I go up 2, I'm already off the graph. But if I go down 2, 1, 2, and over to the left 5, I get a new point right here. And so it helps me graph, okay? Because I can go up 2 and to the right 5. So if it's positive, if the slope is positive, okay, you're going to be going in the same direction. You're going to be going positive up, positive right, or the same direction, negative down, negative left, because a negative divided by a negative is a positive. And that'll help you graph some extra points without even having to do much work, okay? So another example is, well, what if my slope is negative, okay? So again, we want to take B. B is 2. That's my y-intercept. So 0, 2. 0, 2, this point right here in the middle. My slope is now negative 1. What that means is it's negative 1 over 1. So the top is negative and the bottom is positive. But if I flip that, it's also negative. So I could have the top be positive and the bottom be negative, and it's still the same answer because it'll still give you negative 1. So what that means is if I'm going down 1, I'll be going to the right 1. But if I'm going up 1, I'm going to go to the left 1. So with a negative slope, you're doing opposite your rise and your run, okay? So for example, if I want to go down 1 and to the right 1, there's my second point. And then I can do it again. I can go down 1 and to the right 1 again, and there's another point. Or I can start back at the y-intercept. I can go up 1 and to the left 1. As long as one of them is negative, then you're following the slope. And that gives me this nice pretty line, and it is a negative slope. If I read the graph from left to right, it's negative. Okay, I'm going to skip on down. You guys can try these ones yourself if you want. I'm going to skip down to these vertical and horizontal lines. So if I look at this vertical line right here, I ask myself, are all the x's the same or all the y's the same? And so I'm reading it. Okay, let's see. 1, 2, 3. X is negative 3 here. Are x's anywhere else? No, x is negative 3 everywhere on this line. So the equation is x equals negative 3 because all my x's are negative 3. Okay? So with a vertical line, it's undefined. So your slope is actually undefined here, but this is how we would graph it. Okay? With a horizontal line, you ask yourself, are all my x's the same? And the answer is no, but all my y's are the same. All my y's are 1 on this line. All the y's are 1. So y is going to equal 1. Now a horizontal line has a z in it, so that means 0. So this has a slope of 0. Okay, this is where some of my classes ended, so I'm going to stop the notes here and go to the next video. Okay, if you have not gotten that far, then you need to see the next video also.